Something that this segment of our conference is sponsored by Fahal Beton Company, a prestigious producer of ready-mix concrete known for its excellence in the industry, with a focus on enhancing concrete technology for ensuring durability. Uh, this segment's speaker is Dr. Babak Ahmadi, an esteemed expert in concrete technology and durability. His expertise has been instrumental in shaping the standards of quality and performance in the field. He's also associated with the Road, Housing, and Urban Development Research Center. So please join me in extending a warm welcome to Dr. Babak Ahmadi as we anticipate his valuable insights and contributions. Put your hands together for Dr. Babak Ahmadi.
Ladies and gentlemen, I'm honored to give presentation on the topic of effect of temperature on different aspects of concrete. I know that now it's too late, so I try to limit my presentation. All of us are familiar with the topic of hot weather or cold weather concreting, and this is a very common topic in concrete technology textbooks. However, I'm going to present some of our recent research studies outcomes and experience on the effect of temperature on various properties and aspects of concrete. As these topics, as I told you, is the outcome of some research studies in Fahal company, and some of them are done in Road, Housing, and Urban Development Research Center. The first topic I'm going to present is the effect of ambient temperature on ready-mix concrete expense. Usually we don't consider the effect of temperature or different aspects of concrete. For example, consider that who does make a concrete mixture considering the effect of temperature on compressive strength? Usually nobody, but actually the effect of temperature on compressive strength of concrete is enormous. We design concrete mixtures in the lab, in a controlled temperature of lab, about 20 to 23 degrees of Celsius. But in cold and hot weather concreting, some measures should be implemented by ready-mix concrete plant. That's very clear that these measures requires costs, more costs. And as you know, in our country, the price of ready-mix concrete is almost equal during the months of the year, without considering the effect of environmental condition on the price of making concrete. So when we don't take this into consideration, we would have low quality concrete. All of us are familiar with the definition of hot weather concreting and cold weather concrete, so I skip these slides. As you know, we have challenges when we are concreting in hot weather. Some of them are associated with fresh concrete issues, and some of them are hardened concrete issues. For example, in hot weather concreting, we face to increase water demand, increase slump rust rate, and possibility of adding additional water at job site. Or more need to superplasticizer, accelerated setting and construction problems associated with it, increased likelihood of cold jumps, and increased potential of plastic shrinkage and thermal cracks. And in terms of hardened concrete, we may face to decreased strength, the possibility of increased cracks caused by drying shrinkage or thermal gradient, and also reduced durability. And more variability in the appearance of the finished concrete, which is very important in architectural concrete and exposed concrete surfaces. And in cold weather concrete, we have also some requirements. In the Iranian concrete code, we had assigned 32 degrees of Celsius for maximum temperature of concrete. Nevertheless, in ACI 301, it has been assigned as 35 degrees of Celsius. As you can see, our codes are more limited. And also for cold weather concreting, our code is almost similar to the ACI code. The minimum concrete temperature is a function of the thickness of our concrete elements. As you know, Iran is a very hot, very warm country. Most of our cities are located in very warm regions. For example, in Tehran, we have at least 3 months of hot concreting conditions, and in our southern cities like Bandar Abbas, this is extended to about 6 months a year. These results show the obtained compressive strength average of compressive strength of 2 specific concrete mixture during a year. As you can see in the months of the summer, the average 28-day compressive strength is lower in comparison to other months, which can show that in summertime we should implement some measures to compensate for this reduction. Actually, these measures, like using crushed ice, higher amount of superplasticizer, is costly. So the purchasers of ready-mix concrete should get familiar with the significance of this issue. For example, in a project, we used crushed ice about 14 to 40 kilogram per cubic meters, and we use more super plasticizer to enhance the fluidity of concrete at job site for a very normal concrete with the compressive strength grade of only 25 megapascal. As you know, in most of concrete projects in Iran, these normal concrete in this normal concreting, no superplasticizer or no crushed ice is used in even summertime. And as we calculated, the costs increased about 20%. At first glance, 20% increase is enormous. But if we consider the effect of concreting costs on total construction costs, we found that it's about only 0.5%. It means that only 0.5% increase in total cost of construction we face. Although it's very limited, it's very tiny, the quality of concrete has great effect on the lifespan of concrete and performance of concrete in earthquake. In another work, we try to evaluate the effect of using ice crash on the properties of self-compacting concrete and its price also. For this purpose, we made 4 mixtures totally. All the mixtures were the same. The only difference was the amount of water replaced by crushed ice, and also the dosage of superplasticizer was different. In order to analyze the price of the concrete, we calculated the relative materials costs. As you can see, superplasticizer has a big effect on the concrete price. It should be noticed that in Iran, Portland cement is very cheap in comparison to other parts of the world. It's about 1/5 to 1/10 to 1/5 of other parts of the world. But the price of superplasticizer is almost the same. So the price of superplasticizer plays a crucial role on the price of concrete. Also, crushed ice has influential effect on the cost of concrete. In our research, we kept the initial flow of self-compacting concrete about 650 millimeters for all the mixtures. As you can see, in the mixture with the highest level of crushed ice replacement, that is IC60 mixture. 60% of the concrete water mixture was replaced by ice. Had the best slump retention after 90 minutes. With increasing the amount of, as you can see, with increasing the amount of the crushed ice, the slump loss was lower. And at the time of 90 minutes, we retempered all the concrete mixtures to reach the final flow of 700. And the dosage of superplasticizer for redosing the concrete got lower with increasing the used ice. As you can see in this table, in the first row, the relative cost of change due to ice usage increased, and because of using lower amount of superplasticizer, the cost of concrete decreased. But totally, the price of the concrete increased, but it was so limited. But the advantage of using ice crush was using lower superplasticizer at job site, which is not such practical. In other work, we estimated the concrete temperature rise during transport by track mixer in hot weather. There is a formula presented in ACI 306 report for estimating the temperature of concrete at job site when we are subjected to cold weather. In our work, we made a formula for predicting the concrete temperature in hot weather situation during the delivery of concrete. Our results are obtained from about 130 data sets in real concrete delivery. We presented 4 tables for estimating the concrete temperature in hot weather concreting during delivery of concrete. We proposed alpha constant for that formula presented by ACI separately for the night and day. When we reduce the concrete temperature with ice in a day, we reached the average of 0.88 for alpha constant, and for the night it was 0.42. If we do not take measures for reducing concrete temperature with crushed ice, the formula is different. We estimated that concrete temperature increased averagely 1.7 degrees of Celsius per hour in day, and for night it is 1.4 degrees of Celsius. That's clear white. The difference is clear because in day we have solar radiation, which can result in higher temperature of concrete. In another work, we explored the effect of the ambient temperature on chloride diffusion in concretes in different concrete mixtures. We inserted our specimen in 32 gram per liter sodium chloride solution at 3 levels of temperature, 22, 35, and 50 degrees of Celsius for 450 days. We had totally 7 concrete mixtures. Some of them incorporated natural zeolite, and some of them incorporated silicopium, and one of them was a control mixture without any pozzolanic material. And we calculated apparent diffusion coefficient by the second crank solution for diffusion. As you can see in this graph, the depths of chloride intrusion in concrete was higher in higher temperatures. And also, the ambient temperature had an enormous effect on the chloride diffusion coefficient. The coefficient corrosion initiation time could be reduced to above 1/3 with increase of temperature from 22 degrees of Celsius to 50 degrees of Celsius. In other words, the lifespan of a concrete, reinforced concrete in hot weather could be about 1/3 of countries located in moderate conditions. I don't know if I have any time. Okay, I had another research outcome, but I skip it. Thank you very much for your attention, ladies and gentlemen.
Okay, we have time for one question from the floor. If there is any question, please raise your hand. So, thank you very much.
Welcome.